Assalamualaikum. Today our group, which is Hybrid and Power Sdn Berhad, will present a project entitled Wind Turbine Power Generation for course EEE 4947 Electric and Electronic System Design Project. And here's are the members. The CEO of the Hybrid and Power will be Muhammad SYAHIR, and the project engineers are Muhammad FADHLY, Norlin Ilyani and AISYAH.
Assalamualaikum. My name is Norlin Ilyani BINTI KHAIRUDIN. My matrix number 192326.
As for the introduction, our group need to come up with a new plan of using renewable energy and to develop a new electrical distribution system to be supplied into the small populated rural area.
Okay, I will explain on the problem statement and objective for this project. The problem statement are the inability of people in rural areas to get the electrical supply. Second, the people in the rural area cannot use new technology to improve their life. And third, the student in the rural area has a hard time to revise and study, especially at night. The objectives are to promote social equity between urban and rural area by increasing access to electricity in rural area. Second, to lessen the barriers to development of renewable energy sources. And lastly, to provide electricity supply to the household for better education during the pandemic.
Okay, hi, my name is Muhammad SYAHIR bin ZAMASRY. My matric number is 193506. Now I will continue to explain about the simulation of the design wind turbine generator. So the simulation consists wind turbine generator simulation, battery simulation and the inverter simulation. So first we look into the wind turbine generator simulation. It consists wind turbine and the DC machine. So we assume that the speed of the wind is 100 and the constant speed is 1.2, and the output that we want is the current, voltage and the speed of the motor. Okay, this show the output graph for the wind turbine generator. So the first one is the graph for the speed of the motor, DC motor, which is the speed is 2300 radian per second. And the next one is the voltage output for the produced by the wind turbine, which is 230 volt. And the current shows is 3.1 ampere. It shows that the power is approximate to 713 watt. Okay, next is the charger controller of the battery in simulation. Okay, so the battery that we have used is 12 volt with the current output is 2.88 ampere and the battery capacity is 100 ampere. The output that we want to see is the state of charge, the voltage and the current of the battery. Okay, this is the graph show that the output from the charger controller of the battery simulation. So we can see that when the battery reach the 100% of state of charge, it will stop charging. We assume that the initial capacity is 100%, which is 12 volt, and the simulation shows that the battery begins charging shortly after being connected to the generator with a charging current of around 0.7 ampere. We also we can prevent overcharging at the batteries with this charger controller, which will extend the battery life. Okay, lastly is the simulation of the inverter. The function of the inverter in this simulation is to convert the DC to AC. This is from the battery. So basically, this inverter use IGBT, insulated gate bipolar, to get a true sine wave output waveform. So this is the graph of the output voltage from the inverter. So we clearly say that the true sine waveform is formed. So the amplitude, it clearly shows that the amplitude is 230 volt and it is a sine wave. As for the current output graph, it also shows that the current output is also in a sine wave. So we clearly see that the output is 23 ampere from the sine waveform.
List material and cost. Okay, for material we have five main material, which wind blade, DC generator, charger controller, battery, DC to AC inverter. And the cost is project cost is important factor. The type and size are determine the price of wind turbine. Material, first we have wind blade. Wind blade it is used to harness wind energy and drive the rotor of a wind turbine. Second, we have DC generator. DC generator is used to convert a mechanical energy to electrical energy. Third, we have charger regulator. It is used in the system to ensure that the voltage that has been converted by the full bridge rectifier can be controlled to the specific amount of DC voltage, and it also used to prevent overcharging to the battery storage, which it can reduce the life performance and the battery performance and lifespan. Okay, the next one is battery. Okay, battery will use when the battery will operate at night, which supply power to the system, so the turbine can be used in the night, which is we know have wind. Okay. The last one is DC to AC inverter. The input is 12 VDC. Voltage will be converted to 230 VDC. VAC. Sorry. The total to build a wind turbine is 151,544. This include the DC generator, which is 500 ringgit. Charger controller we use 144 ringgit. Battery is 200 ringgit. Power inverter is 200 ringgit. So, and wind blade we have we use our budget is 500. Okay.
Windmill specification, house design and wiring calculation are included in this discussion.
As calculated with the specification in the table, the power generator for the wind turbine is 1260 watt, and according to the Betts law, the theoretical optimum power efficiency of any wind turbine configuration is 0.59, which means that there are no more than 59% of the energy borne by the wind can be derived from the wind turbine. Therefore, we did choose 3.5 meter per second as a mean wind speed and 0.4 as the power coefficient for this project. However, the wind speed may change whether it exceeds or lower from the 3.5 meter per second. And referring to the calculation of the power generated, almost 40% of the energy carried by the wind can be extracted by the wind turbine. Thus, the actual total power generated is 756 watt for a single windmill. In addition, windmill cannot be put too close to each other. Using so would allow one windmill to slow down the wind speed of another windmill. Although having windmills so far from each other is a waste of a ground, usually windmills are not less than 5 times of the diameter of the rotor without losing power.
Hi, my name is FADHLY AZRI bin TAUFIK, matric number 194199, and I will talk about house design and wiring calculation. So, by following the requirement of the task, we need to power up a house consists of 1 living room, 2 bedroom, 1 kitchen. So, as stated in the figure below, we assume that the load of entire house will be 8 unit of 24 watt fluorescent light, 6 unit of 60 watt fan, and last but not least 6 unit of 13 mm SSO. All the calculations are shown in the table below. So in the designing a house wiring plan, there are a lot of things that need to be considered, such as type of lighting used, size of cable, current rating and molded case circuit breaker, current rating and number of miniature circuit breaker. For the lighting, 2 types are usually used to light up the room and a certain area, such as fluorescent lighting and LED lighting. So in this case, we are use fluorescent light because rural area only has a fluorescent light. The miniature circuit breaker for each appliance has been calculated and several current ratings have been determined. The lighting and fan for each room were mixed and protected by 10 mm miniature circuit breaker. The rated current for lighting and fan is only 0.5 ampere as shown at the table below, but the current rating that has been chosen is 10 amp due to high inrush current flow from the ceiling fan. Meanwhile, current rating for switch for SSO is 16 amp. The current rating is a little bit high compared to the calculation because the load that will be connected to the socket outlet cannot be predicted. For the precaution purpose, 16 amp has been chosen for the socket outlet in order to protect the circuit from any leakage or overload. So the detailed current rating for each appliance is displayed at the table below. This single line diagram illustrated the incoming supply by tenaga dan sonar berhad and flow to the kilowatt hour meter. The residual current device is the first circuit breaker that the current will be passed through, then flow to the miniature circuit breaker. Single line diagram is a diagram that shows a miniature circuit breaker assigned for a different location and different appliances. The distribution board, as known as DB, is illustrated based on the single line diagram for real situation. 16mm copper/PV/PVC cable has been chosen for incoming supply wire, left wire to subcircuit and final subcircuit, common bus bar segment for miniature circuit breaker, and neutral wire to subcircuit and final subcircuit. For the earth link, the cable used is only 2.5m copper/PVC cable because only a small current is expected to flow through it, while for the earth wire, the cable used is quite big, which is 10mm copper/PVC cable.
In a conclusion, the main objectives of this project is to successfully provide electric supply to households living in the remote area using available renewable energy. This is because pandemic COVID-19 has affected student learning, where there are a handful of students still living in the remote area. Indirectly, it also can encourage increased social equality between the urban and rural population by increasing access to electricity in the rural area. Additionally, wind energy are far more eco-friendly than the burning of fossil fuel. This energy is unlimited, free, renewable resource, clean and non-polluting ways to generate electricity. Probably, this project can lead to lessen the barriers in development of renewable energy resources and can improve the standard of living of people in the remote area.
Teach us from this detail. That's all from our group. Thank you.